This is exercise 2.3. It is based on polarization of electromagnetic waves. So let us see the question. It says, consider two electromagnetic waves of the same frequency propagating along the z-axis, one of which is linearly polarized along the x-axis and the other along the y-axis. Let the amplitudes of the waves be Ex0 and Ey0 respectively, and the phase of the wave polarized along the y-axis relative to that along the x-axis be delta phi, so that we can write the components of the electric field as Ex z comma t is equal to Ex0 sine kz minus omega t, Ey z comma t is equal to Ey0 sine kz minus omega t plus delta phi. This is the relative phase difference between the components along x and y. And then there is no component along the z-axis. So z-axis is the direction of propagation, and there are two linearly polarized electric fields along the x and y axes having a relative phase difference of delta phi between them. Now the question says, describe the resulting polarization for the following cases. A, B, So these are different cases that are there, and for each of these cases we need to analyze the polarization of the resulting electric field. And finally, the last one is so these are the 6 different cases, and for each of them we need to find out the polarization. So let us start one by one with the first case. So the first case says Ex naught equal to Ey naught and delta phi equal to 0. So in this, if we write down the electric field components, we have Ex, let us consider Ex naught equal to Ey naught equal to some say E naught is equal to E naught sine kz minus omega t, and Ey z comma t is equal to E naught sine kz minus omega t. Delta phi is 0, so we have the same expressions for both Ex and Ey. So this is a case of Ex z comma t equal to Ey z comma t. So this is the case of linear polarization. Linear polarization. Let us draw the coordinate axes and then we will see the polarization. So we have linear polarization of the electric field with this is the resultant electric field. So, and this angle happens to be 45 degrees. This is x-axis, this is y-axis. So because Ex equal to Ey, because of that the resultant electric field makes an angle of 45 degrees with either the x-axis or the y-axis. So similarly, we will solve for all the other parts. Let us now look at part B. So part B is Ex naught equal to root 3 Ey naught. So let this again be equal to some E naught and delta phi equal to 0. So what do we have? The electric fields along x-axis will be written as follows. E along y so Ey naught is nothing but E naught over root 3 sine kz minus omega t. Delta phi is 0. So from this set we get the following. We get E y over E x equals to 1 over root 3. We will take the ratio of these two. So this is 1 over root 3 and this is nothing but tan of 30 degrees. So if we are to draw it in the xy plane, the polarization, we will see the following. This is again linear polarization, by the way. So this is also linear polarization. But in this case is little bit different from the previous case, in that the angle made with the x-axis will be different. This time it will make 30 degrees instead of 45 degrees. So this angle is 30 degrees. This is x-axis, this is y-axis. So both parts A and B are corresponding to linear polarization, but part A is linear polarization with 45 degrees from the x-axis, and part B is linear polarization with 30 degrees from the x-axis. So in part A, Ey over Ex is equal to 1, which is equal to tan 45 degrees. So both parts A and B are linear polarizations, but for different angles with the x-axis. Let us now see part C. Part C says Ex naught equal to Ey naught. Let's say this is equal to some E naught. This time delta phi is not equal to 0. Delta phi is non-zero, which is pi by 2. So in this we have the expressions for the electric fields as follows. Sorry, delta phi here is pi by 2. Now sine pi by 2 plus theta is basically cos theta. So this gives us E naught cos kz minus omega t. Now if we see this in this we see Ex squared plus Ey squared is equal to E naught squared. So this is basically the equation of a circle. So this describes circular polarization. And for circular polarization, we need to know the handedness, whether it is right circular or left circular. So for that, how do we see whether it is right circular or left circular? We can follow the following steps. So for simplicity, we can say look at the z equal to 0 plane. So set z equal to 0, and then we can consider, this is just some steps that you can do. This is just to check whether the handedness is right-handed or left-handed. Then we can consider points omega t equal to 0, pi by 2, pi, 3 pi by 2. So when you consider these points, so from 0 to pi by 2, which direction it takes, which direction the electric field takes, you will come to know whether it is right-handed or left-handed. So these few checkpoints one can consider in which direction the field goes from 0 to 2 pi. So 2 pi will be equivalent to 0. So we just need to see which direction it follows. Even if we do not set z equal to 0, so if we do not set z equal to 0, then in that case we will set this whole phase kz minus omega t to be equal to 0, pi by 2, pi, 3 pi by 2 and 2 pi. So let us apply this set of procedure to our given case. So at phase equal to 0, we have Ex equal to 0, Ey equals to E naught. Then for phase equal to pi by 2, we get Ex equals to E naught, whereas Ey equals to 0. So from this itself, we will get the sense of handedness. So let us plot it. So we know that at omega t equal to 0, we are starting at this point. So let us label the axes. This is x, this is y. So at 0 phase, we are over here. This is at 0 phase. Then at pi by 2 phase, where do we go? We go to this side. Then for phase equal to pi by 2, we come to this point. This is for phase pi by 2. So our direction or handedness is like this. This is basically left. This is clockwise direction. So clockwise direction, circular polarization, clockwise direction, which is also called, so clockwise is called left circular. This is because if you keep your thumb facing out of the paper, so if your thumb comes out of the paper or out of the screen, then if you let your fingers curl along the direction of the handedness, the direction along which the electric field is rotating, then if your left hand, for the left hand, if the thumb comes out, then it is left circular. But if for the right hand, the thumb is facing out of the screen or out of the paper, then it is right circular. So in this, if our fingers curl along the direction in which the electric field is rotating, then the thumb will point outwards only for the left hand. So it is left circular. Circular polarization, left circular. Now let us look at the next part. The next part is part D. Part D says Ex naught equal to Ey naught. Let us set this equal to E naught as usual, and delta phi equals to minus pi by 2. In this case, we will write the electric fields. This is as follows. Now again, if we look at Ex squared plus Ey squared, this is equal to E naught squared. So this is again circular polarization. Now we need to check the handedness. So consider phase equal to 0. Phase is this term kz minus omega t, the argument of the sine or the cosine function. So for phase equal to 0, we have Ex equal to 0, Ey equals to minus E naught. For phase equals to pi by 2, we have Ex equals to E naught and Ey equals 0. So let us see. So for phase equal to 0, we start from this point. This is for phase equal to 0. Then for phase equal to pi by 2, we come to this point. This is phase pi by 2. So that means we are going in this direction. This is counterclockwise direction. And this is called right circular. Because here if you see, if your fingers curl around the direction in which the electric field is rotating, then the thumb of your right hand will come out of the paper or out of the screen. So this is circular polarization, but right circular. The previous part was also circular polarization, but it was left circular. Where delta phi was pi by 2, it was left circular. When delta phi is minus pi by 2, it is right circular. So let us look at the next part. So Ey naught is E naught by root 3. Now let us see this. In this case we have Ex squared plus Ey squared so plus 3 times Ey squared. If we do, then this is equal to 1. Now this is the equation of an ellipse. We can rewrite it as follows. So the major axis in this is the x-axis, because x-axis has a greater term in the denominator over here. This x term, ex squared term, has the denominator as 1 squared. Ey squared term has the denominator as 1 over root 3 squared. So clearly 1 squared is greater than 1 over root 3 squared. So our major axis over here is x. So this is elliptical polarization. First of all, this is equation of an ellipse. So because of that, this is elliptical polarization. Elliptical polarization, major axis is x-axis, and the ratio of major axis to the minor axis. So major axis length over minor axis length is equal to 1 over root 3, which is nothing but root 3. So this is the polarization state. Elliptical polarization, major axis along x-axis, and the ratio of the major axis to minor axis length is given as root 3. So let us draw this on the axis. So this is the elliptical polarization. Now the handedness we need to check. So let us check the handedness. So for phase equal to 0, we are at Ex equals to 0, Ey equals to E naught over root 3. For phase equal to pi by 2, we have Ex equals to E naught and Ey equals to 0. So let us look at these points. So at phase 0, this is the point. This is for phase 0. And for phase pi by 2, we are at this point. So this is like in this direction, this is clockwise direction. This is clockwise direction, or equivalently left elliptical. Finally, we have the last part. So here the expressions for the electric fields would be as follows. Now if we let us consider kz minus omega t to be equal to some phi phase, in that situation we could write the following. We could write Ex and Ey phi plus pi by 4 from these two. We will get the following. We get Ex over E naught is equal to, actually let us consider the other equation. Let us say Ey over E naught is equal to sine phi cos pi by 4 plus cos phi sine pi by 4. Now sine phi can be written from this equation as Ex over E naught So this is Ex over E naught cos pi by 4 is 1 over root 2 cos phi is nothing but square root 1 minus sine squared. So this we will write as square root 1 minus Ex squared over E naught squared, and then sine pi by 4 is also 1 over root 2 . This comes from a bunch of identities that we have used. We have used sine A plus B equal to sine A cos B plus cos A sine B. Then we used that cos theta is equal to square root 1 minus sine squared theta. These are the two identities we have used. So let us simplify it. This is equal to we are just simplifying. So from this we get taking squares on both the sides. So if we square both the sides, we get so let us rearrange some terms. This is going to give us this is equation of a general ellipse. So this is elliptical polarization. This is some general ellipse. Now let us write down the mathematical expression of the most general ellipse. So most general ellipse is given as follows. This is the most general ellipse. Now in this case, the angle of the major axis, the angle the major axis makes with the x-axis is given by the following expression. So angle made by the major axis with the x-axis is as follows. This is for b not equal to 0, else it is equal to 0 degrees for b equal to 0 and a less than c, and it is 90 degrees for b equal to 0 and a greater than c. Now in our case, b is non-zero. So for our case, theta is equal to tan inverse. B is this number over here for our case. This is so minus 1 over root 2. C and A are equal. They both are 1 over E naught squared. So C minus A will give us 0. So 0 minus square root. Again, A and C are equal. So A minus C whole square will be 0. Inside the square root, we will have once again B squared. So B squared is nothing but 2. So this gives us tan inverse of 1, which is nothing but 45 degrees. So in this case, major axis is at 45 degrees with x-axis. So it is elliptical polarization with major axis along at 45 degrees with the x-axis. Now we need to check for the handedness. So for handedness at phase equal to 0, we have Ex is equal to 0, Ey is equal to E naught sine pi by 4, which is equal to E naught over root 2. Then at phase equals to pi by 2, we have Ex equals to E naught and Ey is equal to E naught sine pi by 2 plus pi by 4, which is equal to E naught cos pi by 4, which is equal to E naught over root 2. So let us draw this ellipse. So this is our ellipse, and let us check for its handedness. So at phase equal to 0, we are at the following point. This is phase equal to 0, and for phase equal to pi by 2, for phase equal to pi by 2, we are somewhere this is for pi by 2. So we are moving in this direction. This is again left elliptical. This clockwise direction. Now we need to see the ratio of the major to the minor axis. That will completely specify the ellipse that we have. So for finding out the ratio of the lengths of the major to the minor axis, we will see that the end point of the major axis would be somewhere over here, and that for the minor axis would be somewhere over here. So this is for major axis, and this is for minor axis. Now since this angle is 45 degrees, that is the major axis makes 45 degrees with the x-axis, we know that any line with 45 degrees inclination has equal magnitudes along the x and y direction. So for major axis, we will have the following condition, that Ex is equal to Ey for some value of the phase. So at some particular point, at some particular time t, we would have this condition being satisfied, and that is the point of the major axis. So let us see if we can solve for this. So let kz minus omega t be some phase phi. Let us rearrange it. Here we have used the identity that sine C minus sine D is equal to 2 cos C plus D by 2 sine C minus D by 2. This is the identity that we have used for this expansion, this simplification. Now we clearly know that this number is non-zero, so which implies that phi plus pi by 8 this implies that cos phi plus pi by 8 will be 0, and this in turn means that this argument should be equal to pi by 2, because cos pi by 2 gives us 0, so this further gives us phi plus pi by 8 is equal to pi by 2, which implies phi is equal to pi by 2 minus pi by 8. So for this particular phase, we would be at the end point of the major axis at this point. Similarly, so this is the point phase for end point of major axis. Minor axis would be pi by 2 shifted from this. Minor axis and major axis form an angle of 90 degrees between them. So minor axis would be at pi by 2 less than the major axis, which is nothing but minus pi by 8. So minor axis would be here at this point. Now let us find out the ratio of the lengths by these endpoints for major and minor axes. So when phi is equal to pi by 2 minus pi by 8, that is end point for major axis. This is for major axis. At this point we have the Ex and Ey So as expected, at the major axis, Ey x and Ey are equal, they are equal to E naught cos pi by 8. Similarly, for phi equal to minus pi by 8, this is for the minor axis, we have and then Ey and as expected, this is along the minor axis. This point over here where x is negative and y is positive, but the magnitudes of both of them, x and y, are still same, just the sign difference is there. So now we can find out the length of the major axis. Length of major axis is nothing but E naught squared cos squared pi by 8 2 times this, because x and y magnitudes are same, and then square root. This is equal to root 2 E naught cos pi by 8. Similarly, length of minor axis is square root 2 times E naught squared sine squared pi by 8, which is equal to root 2 E naught sine pi by 8. This comes from the fact that length is nothing but Ex squared plus Ey squared square root. And then finally, ratio of major axis length to minor axis length is as follows. It is cos pi by 8 over sine pi by 8. So let us simplify this expression. Cos pi by 8 is basically 1 plus cos 2 pi by 8 by 2 square root. Similarly, for sine pi by 8, we have 1 minus cos 2 pi by 8 by 2. This comes from the identity that 1 plus cos 2 theta is equal to 2 cos squared theta, and 1 minus cos 2 theta is equal to 2 sine squared theta. So let us further simplify this. 2 cancels, we get square root of 1 plus cos pi by 4 over 1 minus cos pi by 4. This is 1 plus 1 over root 2 over 1 minus 1 over root 2, because cos pi by 4 is 1 over root 2. So we need to rationalize this. So in order to rationalize, we will multiply and divide by the following. So this gives us the ratio of major to minor axis length is root 2 plus 1. So this finally solves the question. This last part is elliptical polarization. It is elliptical polarization. Elliptical polarization in which the major axis is at 45 degrees with the x-axis. It is left elliptical polarization, and the length of the major axis, the ratio of the length of the major axis to the minor axis is square root of 2 plus 1. So this solves this question.